Hello everyone. So in the previous class we were discussing about important terms in entropy. Okay. Let me write it again. These terms are conditional entropy and joint entropy. Okay. So entropy, what I discussed with you, is very important term because we are using it to quantify information. Okay. Why? Because we are having uncertainty in the data. Okay, uncertainty in data. And these are practically understood by considering the events or experiments. Events or experiment. Okay, we may have different events. We may do different experiments. The point is how they are related to each other. So, for a single case, we do write if you are performing an experiment and you are having a random variable x, and x can have any value small x. So, this is how you do write probability. Okay, and the entropy is written as minus px log of px. But yesterday we have seen the concepts. These are conditional entropy and joint entropy. Okay, so we can say that information can be find out depending upon the experiments also, depending upon the events also. And the path of this entropy, obviously, it came from probability only. Okay, we do have conditional probability, pa by b. Okay, where we do write pa intersection b upon pa or pb. This is how we write. This is conditional entropy. Probability, sorry. Entropy can be written as ha by b. Okay, so conditional entropy, just like entropy only, we will refer. So ha by b is equal to minus p a by b log of p a by b. This is conditional entropy. Okay, just like entropy, we can refer this thing. That means if I do have an information of b, can I find the information of a? In probability, we say that I do know about, or I say that b has already occurred. What is the chance of occurrence of a? That we say in probability. But in entropy, I say I do have an information of b. Can I find the information of a? Because obviously na, entropy is related to information only. So this is how we can write the formula for conditional entropy. There is joint entropy where the events a and b two different events, two independent events, can be independent like that also. There are two events. The point is, are they related? That means if they are dependent, then they are related. They are affecting the happening. And conditional entropy, which I just taught you right now, yesterday also I described the entire concept. Here we are talking about B information I know, A information. And probability, that means conditional probability, that means B occurred. What is the chance of happening of A? I did explain you with an example of drink and water. If there is a word drink present, what is the chance that water will be present in the particular sentence? This can be interpreted by conditional entropy. Yesterday only I told. And if I do have any information about this drink word, can I have the information about water word? That will be converted a case of conditional entropy. Now, joint entropy. I do have A, I do have B, two events. I know about them. What are the results? And then I need to calculate the entropy of them. So it is written as again H. No, it's joint. No? P. Sorry, A B. Okay, that is equal to minus P A comma B log of P A comma B. This is joint entropy. Considering both together, what are the outcomes of A? What are the outcomes of B? Consider both together. That is joint. And the relationship between joint, that means the entire system. Now again, one more thing. Joint entropy is the entropy of entire system. Entropy of entire system. That means how much information I can gather from the entire system. It depends. Okay, how many variables are present in it, how many events we did. So if there are certain events happening, okay, in a system there are certain events happening, how much information I achieved from them, that is considered by joint entropy. So in a system there are many things happening, A B C D, the entire information, joint information, if I want to collect, that is being considered by joint entropy. However, conditional entropy do talk about, okay, one happened, what is the chance of happening of another? That's what conditional. However, there is a relationship between these two. They gave a formula. The concepts are something like which I told. There is a difference in the concepts. However, we can write in an equation format which can show the relationship between joint and the conditional. That is joint AB, that is equal to joint A plus conditional of A by B. Okay, that's a formula which we have seen yesterday of joint entropy and conditional entropy relationship. Okay, so both of them are very much important, and these terms are used for many practical problems in information theory. And obviously, one I told, na, conditional entropy. Okay, the prediction of the next term, what it could be. So very much important. Okay, now let me share my entire screen, and I will be talking about the further concepts in information theory. Okay, so here is the entire screen. Okay, so conditional entropy, this is what I told. We do have the next as information gain. Information gain. What is this information gain? So far I was talking about there is randomness, okay, probability, randomness. Why this randomness occurred? Because of sir heterogeneous data. That means mixture. That means this randomness occurred because of impurity in the data. Okay, randomness is because of impurity. If you are having a data which is 0 1 0 1 0 1 0 1, so if you randomly pick any of the digit from here, it may happen that 0 can appear or 1 can appear. So there is impurity in the data. If all are zeros, if all are ones, then if you pick anything, you very well know from here 0 will come, here 1 will come, then there is no information record, no impurity. But here in entropy, we do have the randomness, we do have the impurity in the data. So we are collecting information in that regards only, either by conditional way, either by joint we are gathering the information. Now the point is, if there is randomness, there is impurity, what further you can do? So for that we are having one algorithm, that is decision tree, which uses a concept of information gain. That means the goal of everyone in life is to achieve stability. If you say that, sir, there is randomness in the data, there is impurity in the data, yeah, my system is random, there is, see, if as much as impurity is there, your system is, as much as entropy is there, as much as uncertainty is there. So everyone wants that my life should have to be certain, like uncertainty तो रहती है लाइफ में, देर इज अनसर्टेनिटी, बट फिर भी मैं स्टेबिलिटी चाहता हूँ अपनी लाइफ. We require stability in the life. We want these uncertainties to be reduced. Okay, so if I break a system, if I divide a system, can this uncertainty is reduced? Can this randomness is reduced? Okay, so, and if this is happening, how much information I will get after breaking the system, after splitting the system, after dividing the system? Okay, because if there is impurity in the data, if I can divide, there is a chance, obviously, that you can reduce the impurity, you can reduce the randomness, you can reduce the uncertainty. Okay, so for that, decision tree is one of the algorithm which uses this concept. Okay, and if you know about this algorithm, it's like there is a root node, and these are the children's. Okay, these are the children's, and we keep on splitting. Okay, so here is the entire data, and then we split it. Then again we are going to split it until it's not like saturated, or when there is no randomness. Okay, that means uncertainty is over, so we are keep on dividing it. So if we are having a problem, we are going to solve the problem by dividing it. So as the problems get divided, obviously the certainty uncertainties are getting lesser. Okay, so how is going to help me? I do have a data set that will explain better, that is related to weather data. This is weather data, which is having four features like outlook, temperature, humidity, and the wind. Outlook, temperature, humidity, and wind. And this is my target, whether I can play football or not. Okay, so four features I am having, and I am having a target play. Zero means not play, one means play. So if outlook is sunny, temperature is hot, humidity is high, wind is not blowing, okay, don't play. Outlook is sunny, temperature is hot, humidity is high, wind is blowing, don't play. If this is overcast outlook, temperature hot, humidity high, there is no wind blowing, play. So actually it's a classification problem, 0 and 1. And you can see that in my target I do have a lot of zeros and ones. That means it is uncertain. Sometimes I can play, sometimes I can't play. So there is uncertainty in the data because of the zeros and ones. So mixture हो गया ना zero और one का. यदि सारे zeros होते हैं, if all are zero or all are one, then there is certainty. लेकिन because of zero and one mixture, this is uncertain. Okay, तो क्या करें भाई? The point is we are going to split the data, but from where? That's the question. From where I'm going to split? I will be discussing this thing ahead in detail when I teach decision tree. Right now, I'll give you some hint. I need to consider. See, there are four features present in my data: outlook, temperature, humidity, and wind. There are four features present. I need to split my data about that particular feature that will give me highest information gain. I need to select that attribute, that feature that will give me the highest information gain. So we need entropy concept here because your data is already uncertain. There is randomness in the data. 0 and 1 are present. Entropy will be applied. Okay. And the information gain can be calculated on the basis of entropy by this formula: entropy of a node minus weighted average into entropy of each feature. That is a formula for information gain. That means this is your S source, these are your children's. So S A B. So entropy of S minus weighted average. I need to take the weighted average of A and B. Okay, weighted average of A and B multiply by entropy of each feature. That means entropy of A and entropy of B. Both you have to consider. So let's see how this problem is solved. Now listen carefully. Let's get back to our data set for a better understanding of this formula. Once you understand here, that it will be easier for you in decision tree. Okay. Let us suppose the source entropy is 0.94, which is the entropy of our data. Okay, root, node, this node S. This is the entropy, that is 0.94. And I need to calculate the information gain. And let us suppose that feature is outlook. I am considering outlook. I am going to split my data over this particular feature outlook. It is having three values like sunny, overcast, and rainy. In sunny, I am having 2 yes, 3 no. Overcast, I am having 4 yes and 0 no. In rainy, I am having 3 yes, 2 no. So I can calculate the entropy of each of them. That means sunny, overcast, and rainfall. I can calculate the entropy of them. How? 2 yes, 3 no. Total is 5. So probability of 2, that is 2 yes, that means 2 by 5 log of 2 by 5 minus 3 by 5 log of 3 by 5. This is entropy of sunny In overcast, 4 yes are there, 0 no are there. So this is the entropy of overcast, and this is the entropy of rainy. So I calculated the entropy of these three values which are present in Outlook. What is weighted average? It is the weight of each feature by value by how many elements it has. That means for sunny, weighted average is 5 by 15. How? Why? Because total number of entries present in your data are 14. You can see total entries are 14. And how many sunny are there? 1, 2, 3, 4, 5. 5 sunny are there. So 5 by 14. How many overcast are there? Okay. 1, 2, 3, 4. 4 by 14. How many rainy are there? 1, 2, 3, 4, 5. 5 by 14. So sunny, overcast, and rainy. These are the numbers. Okay. So 5 by 14, 4 by 14, 5 by 14. This is called as weighted average. And then according to the formula for information gain, what it told, entropy of the source, that is 0.94 minus, you have to take the weighted average and multiply by the entropy of each. So weighted average of sunny is 5 by 14. Entropy of sunny, 5 by 14 into entropy of sunny, you very well know, that is just calculated 0.971. So 0.971 plus entropy of overcast multiply by, sorry, weighted average of overcast multiply by entropy of overcast, that is 0. Okay, so multiply this thing with 0 plus weighted average of rainy, 5 by 14 multiply by entropy of rainy, it is 0.971. Okay, so do that, 0.971. So this will give you the information gain, that is 0.247. This is the information gain. Okay, so you have to split tree on that particular feature where I'm getting the highest information. I want to break it on some feature. So selection of a feature is important, and this is the way you do select a feature. Information gain. Okay, so now let me talk more about this in terms of what we are learning currently. Information gain. This is also called as mutual information. So mutual information is the measure of amount of information that is shared between two random variables. Mutual, na? Mutual means how two random variables are sharing the information. It quantifies the degree of dependence or the correlation between the variables. Okay, dependency between the variables, then only they will share the information. Else, why they will share? In other words, it tells us how much knowing the value. This line is very much important, very, very important. It tells that how much knowing the value of one variable reduces the uncertainty in another variable. What do you think about this in real life, in practical? There are two people. Okay, there are two people. Okay, A and B. Or let us suppose there are two friends, A and B, close friends, close friends. Obviously, they do share the information among each other. They do share, close friends and best friends. So they do share information among each other that is been performed. And if there is another person C which know about A, which know about only A, not about B, which know about A. So because A is a friend of B, close friend of B, obviously they do have similar interest. Whom you will make a best friend? Who? किसको बनाओगे अपना अच्छा दोस्त? क्लोज वाला, वही जिससे आपकी बनती हो. The person who understands you, who has the same interest with you, like you, that will be your best friend, close friend. So if C know about A, C doesn't know about B, but knowing only A, do I have do I have some knowledge about B? What do you think? Knowing only A, do I have some knowledge about B? Yes. Is it possible? Knowing only A, can I say that I do have something knowledge about B? Yes. Yes. So it's not like that B is totally unknown. B is not totally unknown. Why? Because you do have a knowledge of A. A shares information with B. They do have a mutual, like, close friendship. And I know about A, what kind of person A is. So he will make the friends like his nature only. उसी अपने जैसे अपने ऐसे वैसे दोस्त बनाएगा वो. So if I know about A, then I can say that B is not totally unknown to me. So knowing A will reduce uncertainty in B. Why? Because I'm not totally blank related to B. I know about A, so at least I can have some thought related to B. That what could be this person? What could be like this person be? So this will reduce uncertainty in B somehow. At some extent, it will reduce. That's what it is saying. Mutual information. Listen again. In other words, it tells us how much knowing the value of one variable reduces the uncertainty in another variable. Okay, if I know about one person, definitely it will reduce the uncertainty. We should view that the light of our previous lecture or correlated features in, yes sir, correlation between the features. Very, very good point raised by sir. Correlation. Because these are mutual friends, they do share the same interest and they do influence each other. Okay, so it appears that there is a information gain in correlated variables with decision tree approach. Yes sir, that's what we do. Okay, what he's saying that in a data, in a data, we do have many features. Okay, in a data, we do have many features: A, B, C, D, many features. Okay, and this is your target. Why? Okay, like 0 1 0 1, something like that. Let us suppose A and B are correlated. Correlated means, okay, there are two kinds of correlation. Let me clear you the point. Correlation. There are two kinds of correlation. One is positive, one is negative. Positive correlation means if A is increasing, B is also increasing. This is positive correlation. Negative means if A is increasing, B is decreasing. This is negative correlation. That means inversely proportional है. हाँ, लेकिन correlation तो है. And what the information gain is saying that if I know about any of the variable present in my data, and if I can know what is present in B or what information B can give. So since A and B are related, correlated, that's what I said. They do share friendship. These are close friends. and they do have mutual information. They do share the mutual information. Correlation, mutual तभी होगा ना, correlation होगा. What do you mean by mutual? Obviously, there should be a correlation, then only we can say mutual terms. Okay, there is an agreement, something you can say, whatever be the term which better suits. So, if there's a correlation, mutual information, all these things, and recheck the sentence. It tells us how much knowing the value of one variable. If I know about one variable, if it is related to another variable, so if I know about this thing, I will be knowing about other variable also. If these two variables are fully, that means directly proportional. If A is directly proportional to B, then if I know about A, I am 100% knowing about B. I know everything about B if they are directly proportional. Why? Because A is increasing, B is increasing, directly proportional, I know. Or if A is decreasing, B is decreasing. This is also a correlation. Decreasing is also correlation. Okay, so mathematically, mutual information between two random variable x and y is denoted by I x comma y. That is defined as I x comma y is equal to hx plus hy minus hxy. You very well know this is entropy of x, this is entropy of y, and this is the joint entropy of x and y. That means overall system, entropy of overall system. This is your information gain. Okay, hx plus hy minus hx comma y. Okay, so here it's said now hx entropy of x, hy entropy of y, hxy joint entropy. Okay, so mutual information is often used in various fields of information theory, statistics, machine learning, signal processing. Okay, just I told, in case of machine learning, in case of data science, you are having the features available. Okay, and we can find the relationship. Okay, because it quantify the relationship between the variables. Okay, that means it talk about the mutual information. It may happen that if the features are not at all related with each other, then there is no information gain. If they are independent, for example, A and B are independent, so what happened with A, it's not putting an impact over B. If they are independent, then you are not going to achieve anything if you know about A, about B. If you know about A, you are not going to achieve anything about B if they are independent of each other. But if they are dependent, then you will be knowing about it. Okay, so we do employ features reduction or correlated features or not? Okay, do we keep the correlated fee? No, sir, we don't keep the correlated features. Now, one more thing, again a good question. In our data, do we keep the correlated features for our model training? The answer is no. A, B, C, D, let us suppose these two features are correlated, highly correlated. See, in real data there is some correlation, I can't deny, no one can deny. In real data we do have correlation among the features, but it's up to you what threshold you are picking here. If you say that if the features, if the variables A and B are 75% or correlated or more than 75% correlated, then in that particular case you have to drop any of the feature, either A or either B, depending. This also depends that which feature is good towards the target. If A is good towards the target, then drop B. If B is good towards the target, then drop A. Don't keep both the features in your model training. If the features are correlated, highly correlated, not only correlated, highly correlated. Highly means this is something I'm for example giving like a threshold value 75%. If A and B are 75% correlated, that means increasing A will 75% increase B, that means B the points of B are coming closer to A. Points of B are coming closer to A. That means we do require model training. That means we want model to learn. We don't want model to memorize. We want model to learn. And learning is about complexity. Learning is the complexity to understand pattern, hidden patterns in the data. That is what model has to do. But if A and B are correlated, and if model captures the point of A, model will easily capture the points of B. Why? Because both are correlated. Where points of A are coming, points B are also coming at the same pace. In the same space, points B are coming closer to A. The model will not put an effort, na? Model will not put an effort. I want model to put effort, because in this particular case, if we are going to keep the correlated features in our model training, model will say yes, I have captured every point present in the data. Actually, it haven't captured. It was capturing A, but B were coming on the way of capturing A. So model captured B also, and model become confident. That is called as overconfident. I captured A also, I captured B also. See how much good I am. But in it's not going to happen every time in a real world. Such kind of models are called as overfitted models. That's why the question which sir asked, relationship, mutual information, correlation, are we going to keep, are we not going to keep? We are not going to keep, sir. If there is less correlation, for example, between A and B, for example, there is 10% of correlation, so no need to drop, because dropping feature is also losing information. There are many twists in data science. If you drop any of the feature from the data, you are losing information ना. आपने यार वो पूरा feature ही निपटा दिया. You had dropped that particular feature, तो information तो गई ना मेरी. चलो कुछ भी था उसमें, था तो सही. So dropping feature, information loss. Don't drop the feature, overfitting, because it is correlated. So you have to take, that's what you are here to learn. Decision making na is very much important here. What to do, what not to do with the data, because that's what the data science and machine learning. You have to play with the data. Okay, so again here, entropy concept, you will not measure the amount of uncertainty in the data, and mutual information is the information obtained on random variable x when y is observed. Okay, y is observed. How much information I can gain about x by seeing y? By seeing y, how much information I can gain? That is called as mutual information. Okay, and this is how we can write it. Information gain is equal to entropy of x minus joint entropy. Okay, minus joint entropy. This. Okay, of the system. Okay, now let's see. Here is the diagram, and there is some places which you can see conditional entropy is also mentioned, because if I check this formula, above joint entropy is mentioned. In this formula, conditional entropy is mentioned. How? Here conditional entropy is mentioned. So, okay, mutual information measure how much information do we gain by knowing X for Y. If we know Y gives all the information of X, the conditional entropy is zero because there is no more information we needed on X. This plays a twist that whether in my formula is it joint entropy or is it conditional entropy? Is it joint or conditional? Joint means uncertainty associated with both X and Y. And conditional means if I know about Y, shall I get the information of X? What is the information of X? That is conditional entropy. So I think this conditional entropy one is looking much more better than the joint. Mutual information, okay, and that's what these lines are going to tell. Mutual information measure how much information I can get if I know about one variable, how much information I can get about another variable. So conditional entropy looks better in the formula. If I get all the information of one variable knowing another variable, then there is no conditional entropy. Why? Because I know everything. Then there is no conditional entropy. It is zero. No more information is required because I know everything. Okay, so the mutual information I becomes hx or hy. It can be like hx or hy, whatever. It can be like this. Okay, for example, if we know label y of an object, we gain a lot of information about image x. We should not mistake its picture with other objects. See, in picture, na, you are having labels. For example, if I label this thing as person, so I know about person. Person can be male, female, per average height could be like 5.5, average weight could be like 50, 60. So if I know about if I just only know this thing label, I can talk many things about it. Okay, person na, so I can talk many things. So that's what we use in image classification on all those concepts. So the information gain ixy is high in this particular case. If I know the label, I can talk many things about the person. Information gain is high, and this is how you can visualize information gain. Okay, so this is hx entropy of x. Okay, this is entropy of x. This is entropy of y, and this is the intersection of the two. Here is conditional entropy h x by y. This is conditional entropy h y by x, and this is what I can get knowing a variable, and I can have the knowledge of another variable. And the formula are written as like this: hx by y equal to hx comma y minus hy, and ix comma y is equal to hx minus hx by y. And this is absolutely correct. This is conditional entropy. This is joint entropy. And just we have seen the formula for joint entropy. Joint entropy is equal to entropy of a variable plus conditional entropy. That's what we have seen. What it did is इसको इधर लेकर आ गया वो. It brought it here. Just change it to y, doesn't matter. इसको y कर दो. So it brought it here. So h x comma y, that means joint entropy minus entropy equal to conditional entropy. Okay, equal to conditional entropy. And then I can find the information gain. That is hx minus conditional, hx minus this thing, hx power. This is information gain. So if the random variables x and y are unrelated, not related to each other, their intersection is empty. Okay, now if the two events are not related to each other, what information I am going to gain from there? Nothing. Empty. Mutual information is zero. But if the random variables are related, for example, if they are same, so knowing x means knowing y. That means y is same as knowing x if they are same. Else, if they are not fully related, somehow out related, so we'll get some information. And this formula you have to apply. Okay. So if you go through certain applications of information gain, decision tree to hai. I just explained you decision tree. We choose a condition of splitting of the data where I'm splitting the about a particular feature where information gain is more. Also, in generative AI, we do have infojans that maximizes the mutual information between the generated image G and its intended label C. That is infojan. So we use this concept of probability entropy in generative. I already told you these concepts are evergreen concepts. We can't ignore it. Till generative AI, they will be used. So this encourages Jan model to generate images related to the label. For example, the label is person. So the Jan will produce the images of person. It will not produce image of apple. It will generate the image of person. Because we do have an information that okay, person and how the person looks like. Okay, so the information gain will be used as a part of training objective. Fine. This is a formula for mutual information between label and the generated JANs. JAN means generative adversarial network. Okay, if you don't know about that thing, this is a part of generative AI. JAN means generative adversarial network. This network, it's a deep learning network. Okay, which is having two components. One is generator, one is discriminator. Two deep learning architectures are there, and the idea is to generate fake images. Okay, so that I'm not going to tell more about it. Just remember. So we use this concept of mutual information there also. Okay, fine. So let me again recap how far we came till minus log p Shannon minus p log p entropy minus p log q cross entropy minus p log p by q KL divergence. Okay, KL divergence. Then minus p by q log of again p by q conditional entropy minus pq log of pq joint entropy and p minus sorry okay p plus p by q information gain. Also these two joint entropy and conditional entropy can be written as the joint entropy, that is pq, can be written as p plus p by q. So this is joint and this is p, this is p by q conditional, and this is information gain just right now. So all these terms you can write the formula. Okay, this is how they can be represented from Shannon till here. Information gain. It's mandatory for you to revise all the concepts and to write the formula and how they are applicable, certain use cases. Okay, so information gain, application in machine learning, information you know. Okay, and example I gave, that means if I say I didn't go to work, this is not giving me the proper information. I didn't go to work because I had a doctor appointment. This is giving me the entire information. So information is everything. Okay, so second message contains more information than the first message. So we did quantified it with the help of Shannon formula, information theory. That's it. So in 1900s, that means in 1948. Right now we are living in 2024. Maths is something, which will be like years and years and years. It will not just change. These persons are so smart, intelligent people. So Shannon published an article, a mathematical theory of communication. That means how much thought they do have. The only point is how much practical they are. Okay. So he published an article in 1948 that if I need to quantify information, it can be written as minus log p. This paper gave birth of entire concept information theory, which is used in your right now we are doing in machine learning and data science, computer science, economics, statistical physics, everything. Okay, so that brought concept of entropy. Here is what the entropy is. Okay, we have studied this thing. Okay, so entropy is entirely dependent upon the probability of a random variable, not on the value of x itself. The random variable, that is the probability of the random variable. It can be like positive or zero. If the entropy is zero, no information is information. That's what we have seen in example also, tossing of a coin. Joint and conditional entropy, I also explained you what they mean. Okay, in machine learning and probability, joint probability refers to the likelihood of two or more events occurring simultaneously. Joint probability. Okay, that means P, A, and B is joint probability. Okay, P, A, and B is joint probability, where A and B are the events, and they measure the probability of the intersection of the events. Okay, okay. Let's see. Just take an example to make it clear, more clear. For example, this is event A. The outcome is 2, 4, 6. This is event B. The outcome is 4, 5, and 6. Their intersection is their intersection is like if you want to find the joint probability of event A and B occurring together, which is the probability of rolling an even number greater than 3. Okay, what is event A? Event A is the outcome of an outcome is an even number. What is event B? The outcome is greater than 3. We are having two different events. Rolling of a die, but we are saying two different things. Rolling of a die, we are saying that okay, even number can come. Also, we are saying that the outcome should be greater than 3. That is the second event. So 4, 5, 6 are the outcomes, 2, 4, 6 are the outcomes here. 4 and 6 are common in these two. So the total number of outcomes on a six-sided die is, what are the total number of outcomes? How many I got? 2, 4, 6, 4, 5, 6. 6. Total 6 outcomes are there, in which 2 are my common outcomes. So 2 by 6, 1 by 3. This is joint probability. So rolling of a die, giving even number, and getting a result greater than 3 is 1 by 3. This is joint probability. Now I hope this made things very easy. Okay, we are considering role of a six-sided fair die, and two events happen. One is even number, one is greater than 3. So we find out that who are the common outcomes and divided by total number of outcomes, that is the joint probability. However, joint entropy is a measure of uncertainty or disorder associated with joint probability distribution. It quantifies the amount of information. It is written like this: px comma y log px comma y. That's what I explained. Okay, so px comma y, that is the joint probability of x and y. Okay, px comma y is a joint probability of x and y. Okay, so let us say if we do have a system, consider a system with two binary random variable x and y which are having value 0 or 1. So the joint probability distribution is given as like this: x is 0, y is 0, joint probability is zero point 0.2. X is 0, y is 1, joint probability is zero point 0.3. X is 1, y is 0, joint probability is zero point 0.1, and so on. And now, if I need to calculate joint entropy, so joint entropy is given as summation of px log of px. So zero point 0.2 log of zero point 0.2 plus zero point 0.3 log of zero point 0.3, zero point 0.1 log of 0.1, zero point 0.4 log of zero point 0.4. This is joint entropy. Okay, this is joint entropy. Quite easy. And we are taking log to the base 2. Remember. Okay, log to the base 2. Because we are quantifying the information in bits, so we are having 0 and 1 2 bits, so that is why log 2. There could be like a question can be asked like why you are taking log 2. Because 0 and 1 information is in bit format, signal 0 1, high voltage low voltage, so log 2. Okay, fine. So joint entropy, formula for the joint entropy. Okay, fine. Conditional entropy, I already told you again. This came into the picture because these are the concepts which are repeated and main concepts these are. All right, fine. So it will take me a day more to finalize. I hope day more is okay for to explain. Huh, okay. Okay. Hmm. Let me stop sharing. All right. Let me stop recording.